I'm Frank,
I'm Tim.
and today we'd like to analyze the typewriter's impact in design, as well as discuss its machine design principles. Now, the main purpose of the typewriter is to transfer the force from a key press into moving a printed shape to imprint onto ink and create letters on paper. Now, in essence, this removes the need for any manual writing and can speed up document typing very much. And this had multiple effects on society, including accelerating social change and allowing businesses to extend further thanks to how easy it was to create typed documents. And as well, this also opened up new job opportunities for many workers that were new to the industry. Now, many people had tried to create something like the typewriter in the past, but it was very difficult due to the amount of complex machine designs that were necessary. And it wasn't until 1872 that a man by the name of Christopher Latham Scholes was able to make it after about 4 years after submitting a patent. Now, soon after that, it became a commercial success, and many others tried to add on to it, including a shift key 6 years later and the eventual evolution into an electric typewriter by the time 1920 rolled around. Now, with such small parts and a lot of moving parts, there were plenty of issues with the design, and it could break down easily. And the first thing was that because there were so many complex moving parts, it needed to be cleaned and oiled regularly in order for it to work properly. And as well, it could also experience fatigue due to the springs having to stretch and compress constantly. And as well, the bands that used to transfer the force from key to paper were put under a lot of pressure, and sometimes they were able to slip out of place or snap completely. And as well, because the machine was so tiny and flimsy, a lot of the parts experienced lots of vibration, and because of this, the keys and other parts could fall out of alignment, potentially ruin the whole design. Now, the mechanical advantage of the typewriter is very difficult to estimate due to how many moving parts there are, but we can make a rough approximation due to the fact that there is a spring that absorbs force due to the amount of resistance inside of it. And as well, the interaction between the cam lever and the type bar causes a leverage, which increases the amount of applied force. And we estimate that these two forces could roughly cancel out, and we're left with the 1-to-1 ratio of mechanical advantage. And I'll move on to Tim's section so he can talk about the part synthesis.
Yes, so we made a couple observations about the shape synthesis of the typewriter. Our first one deals with part synthesis, and we were observing the leverage principle within the typewriter. So on the right, we have a bit of a cross-section of the inside of the typewriter. And as you can see, by using a long key arm, a small amount of force of a keystroke can lead to enough force to print a letter onto a piece of paper. So that uses a leverage force by creating a long arm that transfers the force input by the user to create a faster force, a faster velocity in the part, which can print the key or the letter on the piece of paper. So the second observation we made is another part synthesis observation, and it's involving the direct path principle. So the key violates the direct path principle because it needs to move up and down to create enough leverage to activate the type bar. So the force is going directly into the key, but there's where the force is going is not directly underneath the key, which in direct path principle says it should be. So the reason it violates this is because it needs to have the up and down motion to allow the key to create the force and the leverage to work the rest of the machine. The third observation that we made is a joint synthesis observation. So this observation is called the few large fastener principle. So there's the many small fastener principle or the few large fastener principle. For the most of the parts inside a typewriter, they need to rotate, meaning we can't have a bunch of small fasteners prohibiting these parts from rotating. So you need one large fastener at each of the joints connecting each part together, which is a very good reason to use large fasteners. And so since the inner mechanisms of a typewriter need to rotate to function, one large fastener is used to bind them together. And this could be part to part and also to the parts to where they're mounted to, so to the shell of the typewriter as well. The fourth observation is another joint synthesis involving preloading. So there's a lot of thin rods connecting some of the parts. And these rods, if a large compressive force or even a smaller compressive force is applied to them, could cause them to buckle. So the thought is that these must have been manufactured in a way that they are preloaded with a tensile force so that they're always under tension, even when in use. So we don't have to deal with that issue of prevent possible buckling. And the fifth and final observation is another joint synthesis using the mating surface principle. So the mating surface principle involves making sure there's a lot of surface area around different joints to make sure that the force is distributed across the joint. So each of the parts wrap around the entire fastener that are connecting them together, which makes sure that the load is distributed evenly and there's not one source of higher stress. So this is we have a couple improvements that we could make to the design, possibly to make it a better product in general. So the first improvement would to be the thin rod and how they're assembled. So we have all these thin rods that are within the typewriter that sort of connect pieces together. They don't really rotate, they just sort of translate. But as you can see, they're bent into the pieces. They have to be bent to create, to be put into the pieces. And even though they're probably always in tension, there's always a possibility that these could become unbent and they could fail or deform. So a possible improvement could be to bend them at least 360 degrees, making sure that there's more surface area between the two parts and make sure that the force is distributed more evenly. The second improvement is to maybe use lock washers on a lot of the joints that rotate. So a typewriter, the way it works is that each part is going to go up and then down. It's not a constant rotation in one direction. It rotates in both directions as you press the key up and down. So the pieces that have rotating capabilities, the nature of it is that the fastener or the nut that is connecting them to the shell of the machine is going to be rotating in both ways as well. And since it's threaded in one way it rotates is going to make it become looser, or at least apply force that could possibly make it become looser. So the use of a lock washer could prevent either way of rotation from preventing it from becoming looser and possibly failing. So that is the end of our presentation about typewriters and shape synthesis. I hope you enjoyed it, and that is all.